Activity 13.7, again, measures of variation, but now we're going to look at the mean absolute deviation, abbreviated MAD, and standard deviation. What you'll see in K8 is MAD. What you'll see on standardized test reports that you will get as a teacher is standard deviation. So we're going to look at both. There are pretty straightforward formulas here. There's one for math, there's one for standard deviation. Some students find it very helpful to put the data into tables. There's an example of MAD, an example of standard deviation. So there's a set of data, 2020, 30, 30. That means your N in the formula is 4 because there are 4 data points. In the formula up here for MAD, it says the very first thing, X bar, which is your mean. The mean right here is 25 because it's 20 plus 20 plus 30 plus 30 divided by 4, which gives you 25. The X sub 1, 2, 3, and so forth are your actual data points. So the data points we're working with are 20, 20, 30, 30. We're going to take the mean, 25, minus the data point, and you get a number. It's okay for that to be negative because then what we're going to do is take the absolute value. That's what makes it positive. And then we're going to find the sum. That's all these pluses up here, and we're going to divide it by n. So we're going to take the sum, which is 20. We're going to divide it by 4, and I get a mean absolute deviation of 5. Very similar, but not quite the same, is standard deviation. You still find the mean, you still list your data points, you still subtract the mean minus each data point, but now we're going to square them. That's how the standard deviation gets rid of the negatives. In MAD, you do the absolute value, which we know is the distance from 0 is always positive. When we square something, we always get a positive number as well. We're also going to divide it by n, and then we're going to do the square root because the square root will undo the squaring that we did. In this example, when we do that, we actually get 5 again. MAD and standard deviation are not always going to be the same value. So for this, by the way, n is also equal to 4. That is in your formula. On the next page, you get different sets of numbers, and we want to look for MAD and standard deviation. The first two are MAD. The next two, C and D, are standard deviation. If you want to figure out the mean first, so we're going to figure out the sum, which would be 250. You have 1, 2, 3, 4, 5 divided by 5 would be 50. Your data points are 0, 25, 50, 75, 100. We're going to take our mean minus the data point. Oops, not 150. Okay, then we're going to take the absolute value. We're going to have to add all these up again. So 150. And then MAD be 150 divided by 5. And that should be 30. So what does this mean? This means that a standard deviation or a mean absolute deviation is, on average, the distance every single data point is from the mean. So right here, our mean is 50 on average. Every data point is 30 away from the mean. If I go back to the first page and look at these numbers where I had 20, 20, 30, 30, the mean was 25 and my MAD value was 5, which makes sense. If your mean is 25, that's right there in the middle. 20 is 5 removed from that. 30 is 5 removed from that. Each data point, by the way, is 5 removed from it. So on average, these data points are 5 removed from the mean. On average, these data points are 30 removed from the mean. Okay, I'll let you work on B, and let's go to C together. So very similar, we're going to find mean, which it's the same set of numbers as we just used. So I already know that the mean is 50. I will then, if I'm looking at my example on page 1, I'm still going to subtract, but then I'm going to square. So I can just copy down what I did on the top here. Okay, so you'll need a calculator because we're going to need to square those. I know this is 625. 5 times 5 is 25, so 2,500. So I need to find the sum. It's barely going to fit with 5,000. 6,250. So now your standard deviation is going to be the square root of 6,250 divided by 5, because that's n, you have 5 data points. This is the square root of 1,250, which is about 35.36. So here's an example of where the MAD and the standard deviation are different. So do the same for B and D. B is MAD, D is the same number set, but you're looking for the standard deviation. Just one more page here. And this is really looking at our graphs. And this is a graph of some examples. Graph 1, the 20, 20, 30, 30 was the example we did on the first page of this activity. And then the 10, 20, 30, 40, 50, 60, 70 is actually your B and D that you're going to do on your own. So just looking at these graphs, we want to describe the variability in the data. And describing variability in data is one of the standards that your students will have to know. The lower your MAD value and standard deviation, the less variability in your data there is. The larger your MAD value and your standard deviation, the more variability or spread out your data is. So when you're looking at the first one, and we did this in example 1, the both MAD and standard deviation was 5. So what you'll need to do is figure out MAD and standard deviation on the previous page, and they should be higher than 5 because your data is much more spread out. Thinking about what standard deviation and MAD is and the way you calculate it, if you have a data set where all the data points are the same, what should your MAD value, if it's the average distance from the mean, what should the MAD and the standard deviation be of this? But I don't want you to calculate it. I want you to think about it and think about the value. And then describe the variability of this graph. You can do it based on your MAD and standard deviation value in F, or you can look at this graph and figure out how spread out your data are.